David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. One quick comment before we start. This video is made from 2 separate videos that each talk about distance and midpoint formulas in 3D. Now, in those videos, we introduce those 2 formulas first by discussing their 2-dimensional version, and then using that version to explore some of the more complicated problems, then finally move on to the 3D version. If you're feeling like you'd like a more comprehensive treatment of this topic, then I would suggest you click down into the description and watch the 2 individual videos, one for midpoint and one for distance, so you get a better understanding of how this all works. The video that follows here only discusses the 3-dimensional versions of midpoint and distance. Okay, we're going to move on to the 3D midpoint formula, but first I need to introduce you to 3D space. Not quite the final frontier, but it's new. Okay, so what I've done is I've drawn a 3-axis system here. Now the challenge with 3D space is that we're representing it on a 2D plane, so you have to kind of use your imagination. This would be the x-axis, this is the y-axis, and the z-axis is the vertical axis. Okay, so we could plot a point here by measuring over on the y-axis some amount, down the x-axis some amount, so that point would be right like that. So this would be our xy coordinate, and then we could come up a z level, and this point would be x, y, z. So we've graphed a point in 3D space. You can think of it as this axis is coming out of the board, and this point is like out here somewhere in the air. Okay, now that we understand 3D space, let's take a look at the 3D midpoint formula. So for any points, x1, y1, z1, remember in 3D space you have 3 coordinates, x1, y1, z1, and x2, y2, z2. The midpoint formula will be, now this is not a surprise, this is very similar to the 2D formula. So see if you can think of what that might be. Okay, here you go. M equals x1 plus x2 over 2, comma, y1 plus y2 over 2, and big surprise, z1 plus z2 over 2. It's pretty much the same thing as the 2D one, you just have a third D. Okay, let's do a cuboid problem and find a midpoint. A cuboid is just a rectangular box. It's not a cube, because it could be a rectangle, so it's not all squares. And I've sketched in a cuboid on our coordinate plane with our x, our y, and our z axis. And this is 3D representation on 2D plane, so you might need to look at that a little bit to make sure you understand that this front here is out from the board. And then the back is there. This is a cuboid, or a rectangular box that has 6 faces. And I've ticked off on my coordinate axis all the units, so we can figure everything out. Okay, so find the midpoint of diagonal AB. And what I've done is I've listed this back top corner and this front bottom corner. So the diagonal would go between those through the center of the cuboid, and we need to find the midpoint of that. So to do that, think about what your first step would be. Okay, your first step is to figure out the coordinates of these 2 points. Once you have that, then you can just plug it into the midpoint formula and it will give you that midpoint. So pause the video and see if you can figure out from this diagram what the coordinates of A are and what the coordinates of B are. And remember, those coordinates are in 3 dimensions, so they have an X, a Y, and a Z. Okay, let's take a look and see how you did. A, the coordinates of that are going to be the X coordinate. That's how far it is out on this axis. And guess what? That's not. That one is right there. So the x coordinate is 0. It hasn't moved out on this axis or that axis. It's just moved up on the z axis. So the x coordinate is 0. And how about the y coordinate? Also 0. And then the z coordinate is 1, 2, 3. So 0, 0, 3 is the coordinates for point A. And the point B, go ahead and pause the video and see if you can figure that out. Okay, let's see how you did. B is going to be, check it out, see we're this far out on the x-axis, so that's 2 out. This line is the same distance along the x-axis, so the x-coordinate for B is 2. Now the y-coordinate for B is going to be 1, 2, 3, 4, because this line is 4 out the y-axis, so y-coordinate is 4, and then the z-coordinate, that one is 0 in this case, because we haven't gone up. We're still in the xy plane, the flat bottom of the rectangular box. Now, if figuring out these coordinates is challenging for you, you might want to practice. You are going to get some practice in the exercises, but sometimes visualizing 3D on 2D is a little bit complicated. Okay, so now we have our 2 coordinate points that we need to find the midpoint of. Remember, we're finding the midpoint of the segment that goes from the back top corner A to the front bottom corner B. And this is top left, and that's bottom right. Okay? So that's a diagonal that goes through the middle of the rectangular box. So go ahead and pause the video and plug that into your 3D midpoint formula and see what you get. Okay, so here's a little trick. x1, y1, z1, x2, y2, z2. Just to be sure you know where to go. Now the plug-in step will be x1 plus x2 is 0 plus 2 over 2. The y-coordinate will be 0 plus 4 over 2. And the z-coordinate is going to be 3 plus 0 over 2. So this is kind of shaping up in an interesting way. We have a 0 on the top for each of these 3 little fractions. Let's finish this out. The midpoint is going to be 0 plus 2 is 2 over 2 is just 1. 0 plus 4 is 4 over 2 is 2. And 0 plus 3 over 2 is going to be just 3 over 2, or 1.5. Just like that. Now, we can plot this point just to make sure that it makes sense to us. So we're going to be 1 out. That's the x-coordinate, so it's going to be 1 along here. And that makes sense. That's halfway between the origin where that corner is and this corner. So that is a midpoint of that part. And then it's going to be 2 along here. So it's going to go 1, 2. And it's going 2 along the side that's 4. So that makes sense. That's halfway. And then we're going to go 1.5 up. And 1.5 up is halfway from this corner to the A. So that makes sense. So our midpoint will be right there. And this is our diagonal. It's like that. Now it's a little hard to see because this is coming from the back side to the front, but I think you get the picture. Okay, let's move on to the 3D distance formula. A little more complicated, but pretty much the same idea. So what we have is for any 2 points, x1, y1, z1, remember 3D space has 3 coordinates, x, y, and up. So 2 points, x1, y1, z1, and x2, y2, z2, the distance is, check this out. This is the same as the 2D distance formula, you just have another term for your z-axis. Otherwise, it's the same type of a formula. Okay, so we're going to bounce around on this problem for a little while. What I've drawn here is a cuboid on a 3D coordinate plane. Remember, we have x, y, and z is your vertical axis. And then I've drawn my cuboid in here, and I've labeled my axes, my corners. So I have A, B, C, D around there, and then I have R, Q, F, and O around there. So, and then notice how we've given you the coordinates for one of the points, point A. It's 2, 3, 4. So that's 2 out on the x-axis, 3 along on the y-axis, and 4 up on the z-axis. So remember, 3D space is a little bit more complicated than 2D space. So here's your first question. What are the coordinates of Q, F, O, and R? And you might look at that right now and go, what? How the heck could I figure that out? There's a key thing that helps you do that. This back bottom corner of our cuboid is on the point 0, 0. So everything else goes out from there, and you can figure everything out. So I want to do 0, 0 first.
or O, point O is 0, 0, 0. So O is 0, 0, 0. That's great. So now let's take a look at R. So R is scooting along the x-axis the same amount as A has come out from the back. So you kind of have to visualize that in 3D. But point A is 2 units along the x-axis, and it's going to be the same distance as point R. But R is not going along the y, and it's not going up on the z. So R equals 2, 0, 0. Okay? Now, it can be a little confusing, but you can get the hang of it if you keep working it. Let's do Q. We know what R is, so now we can just go up to Q. So Q is going to be, so check it out, the x-coordinate of Q is also 2, because we've come out the x-axis by 2. But now we've gone up on the z-axis. How much? We've gone up the same amount A is on the z-axis, and that's 4. So this point is going to be 2, 0, 4. And it's 0 in the y, because here we haven't yet gone along the y-axis. So the y-coordinate here is 0. Now our last one, let's see, we did O, R, and Q. We've got F. I'm going to squeeze F in right up here. Now F, this one's interesting. It's not gone along the x-axis, so that's a 0. It hasn't gone along the y-axis, so that's also a 0. It's just gone up the z-axis by the same amount that A has come up the z-axis. So F is going to be 0, 0, 4. Now, figuring out points like that is going to be essential to working some of the problems. So that's why I took a little extra time with that. Now, here's an IB-style word problem question. So let's read it off and then I'm going to see what you can come up with. What is the max length for a garden tool that still fits in the shed? And let me give you a little context here. You might have noticed that I wrote up here Cuboid garden shed, right up here. So yeah, it looks just like a box on a diagram. But let's pretend that this is a shed where you can store garden tools like rakes and hoes and shovels and all the things you need to work on your garden. So what they want to know is what's the longest tool that we can store in that shed? The max length. So pause the video and think about that for a minute. Maybe just come to a qualitative idea about how that would work and what that would be on the diagram. What distance would that be? Okay, let's take a look. So the longest tool would go in one corner and it would go all the way through the middle of the cuboid of the shed and it would hit the opposite corner on the top side. So that's the longest possible tool. So what we need to calculate is the length of a diagonal of a cuboid or of a rectangular box. Okay, so we just need to calculate the length from A to O. Now here's the thing. We could calculate there's like 4 different diagonals that can be drawn. There's A to O, there's D to F, there's R to B, and there's C to Q. Those are all diagonals of our rectangular box, and they're all the same length. So let's pick the one that makes it the easiest. Pause the video and see if you can figure out which one that might be. Okay, if you said, well, of course, let's use this one, you're right, because point O is 0, 0, 0. And so that means we plug into our 3D distance formula, one of these 2 numbers in each of these little binomials is going to be 0. So that just makes it a little bit more simple. Okay, so now we know that we're calculating the distance of a line that goes from 0, 0, 0 to point A, which is 2, 3, 4. So go ahead and pause the video and do a plug-in step with your distance formula. Okay, so let's see how you did. I did x2 minus x1, that's 2 minus 0 squared. And here's my x1, that's 0. And I labeled my points, x1, y1, z1, x2, y2, z2. And I finished plugging it in. Y2 is 0 minus y1, which is, y2 is 3 minus y1, which is 0. And z2 is 4, and z1 is 0. So there's your plug-in step. Go ahead and pause the video and do the calculation if you haven't already. Okay, let's see how you did. My answer is 5.39 to 3 sig figs. Let's do the reasonableness test, okay? So take a look at your box. You notice this dimension is 2, this dimension is 3, and that dimension is 4. So if a diagonal of the box is 5.39, that makes sense. It's within the realm of possibility. If we got 1, that would be bad. If we got 20, that would be bad. Okay, one last little problem. This one I think you can just get without me doing anything. Find the height, RQ, of the garden shed. Pause the video and figure that out. Okay. There's no calculation here. You can just tell from the diagram. So I'm going to change one word. List. Okay? List is an IB term that you should pay attention to. Like list and state mean that you should be able to just pull the information from the problem. Find indicates that you need to do a calculation. Now, we could calculate the height of the box, but we can list it because the information's right there. So, see if you can do that. Okay, check it out. Let's see how you did. RQ is right there. Okay? So now that I've pointed out RQ, see if you can figure out what the height is. Okay, check it out. RQ is just the distance we've gone up the z-axis. That's all it is. It's the height of the box, which is what they're saying. So that distance is right here. That's the 4. Our z-coordinate is 4 up. Remember, this point here is 4 up from the bottom, from the origin. So we've come 4 up to A. Q is the same height as A, so RQ is 4. There you have it. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that didn't go in so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.